Hey guys, back with almost done with chapter 10. We will finish it tomorrow, Thursday, and we might march. We're just going to go right into chapter 12. Okay, here we go. Jokes. This one's a mean one. What did the cowboy say when the bear ate Lassie? Well, doggone. Where does a Rottweiler sit at the movies? Anywhere it wants. That's it. And you're going, that isn't the best joke. What do you get if you cross a dog and a cheetah? A dog that chases cars and catches them. Maybe that was better. You're all going, oh gosh. And that's the highlight of the lesson. So, okay. So I want to pick back up to where we left off. I want to do this problem. So here was the problem I had in the notes. So this is where we finished in the notes. Okay, so I want to do this problem and kind of pick up where we were. But to do a problem like this, you have to be given the specific heats of ice, water, and steam. And another thing that you've got to be given, which wasn't given here, is you've got to be given to the heat of fusion and the heat of vaporization, or usually it's water, but in whatever problem. So anyways, you should note that again, I gave you the values for ice, the specific heat for ice, water, and steam, but you would need the heat of fusion and the heat of vaporization. And you'll see that as I do this problem. Okay, so I want to do this problem. So it says how much energy is needed to heat 36 grams of ice at negative 27 degrees Celsius to steam at 120. And like I was saying in class, I think it's number 4 on the quiz. Is just like this. Okay, so to me, in doing this problem, I just am going to really follow in the diagram where we are in the diagram, the calculation that goes with it. So we have 36 grams, and the units are really part of this problem. So we're starting with 36 grams of ice at negative 27. So we're really starting right down here, and we're going to end up to steam at 120. So we're going to end up here. So we're going to do 5 different steps. First, we're going to take the solid ice and make it where there's liquid. Then we're going to melt it, step 2, and then we're going to take the temperature of all the liquid and we're going to increase its temperature to where it's at the boiling point. And then step 4 will be liquid to gas, and then finally step 5. So in this diagram, let me kind of show you here. I'll label this. So to me, the heating cooling curve kind of helps me with this. So step number 1 is going to be, what we're going to do here is we're going to get ice. We're going to get ice from negative 27 to 0, to the melting point. So warm ice. So warm ice, and this is where I'm going to use this, which again, you have to be given the specific heat of ice. So we're going to do Q SMAT. And one thing about this, so whenever the temperature is going up, so here, 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 we're going to use Q SMAT. Whenever the temperature is flat, so we're going to use the heat of fusion, the heat of vaporization. So it's going to kind of be a different calculation. Okay, so here, so I've got the specific heat of ice, 2.03, which was given to me. And the units are part of this. The mass, it says it was 36 grams. And the change in temperature, we're going to go from negative 27 to 0. Okay, so if you look at the units here, grams go, degrees Celsius go, and I'm left in joules. So what that gives me is 1,973 joules. And this is where I'm going to come back. I'm going to look at the sig figs at the end. Okay, and then so that got me from here on the heating cooling curve. So what I did is I took the solid ice at negative 27 and I got it to 0. Okay, step 2 is going to be here, and this is where you have to be given the heat of fusion. So step 2 is going to be to melt the ice. Okay, so step 1 was to get the ice from 0 to, or or from negative 27 to 0. Step 2 is going to be to melt the ice. Okay, so here I'm going to use, and again, this number has to be given to you. You can do this problem. This here is the heat of fusion. So you have to be given that number. And I'm going to do all 5 steps, and then I'm going to add everything up. And I'm going to multiply it. And if it's 36 grams, this is water, I'm going to get this into moles. Okay, so because this is moles, this needs to be moles. So moles cancel out. And what I get there is 12.04 kilojoules, but I want the units to be consistent, and since this is joules, I'm going to get this into joules too. So 12.04 kilojoules is 12,040 joules. Okay, so here was the energy it took to increase the temperature from negative 27 to 0. Here's the energy it took to melt. Notice it took significantly more energy to melt it. Okay, so the third step now is going to be to warm the liquid. So this is going to be step 3. And this is where, again, whenever the graph is going up, wherever the graph is going up, we're going to do Q SMET. So step 3 now is going to be to heat the water to 100. So that means, again, I'm going to use Q SMET. But this time, I have a different S. Okay, this time I'm going to use the specific heat of water. So this was the specific heat of ice. So the mass is 36 grams. And again, notice here I use moles because of the unit. Here I'm using grams because of the unit. And the change in temperature will be 100. And my unit here will be joules, just like it was there. So this gives me 15,062 joules. And in the end, I'm going to add all these up. Okay, so that got the water up to here. Now in step 4, now I'm going to evaporate the water. So now I'm going to go from the liquid to the gas. So here I'm going to boil the water. Okay, and again, this is one. Just like here, you had to be given the heat of fusion. Here, you have to be given the heat of vaporization. I'm not going to expect you to memorize that. I'm sure the AP test is not going to make you memorize that. So since this is moles, just like I did here, I'm going to use 2 moles. Just make sure my units are straight. And that gives me 81.2 kilojoules, which is 81,200 joules. So if you look at that, and again, you compare these numbers, 1973 to just get the ice to 0, 12,000 to melt the ice, 15,000 to go from 0 to 100, 81,000. And this is a good kind of, well, why? Well, you're breaking a lot of intermolecular bonds to go from the liquid phase to the gas phase, and that takes the most energy. And now the final step, let me go back to my diagram here. So my final step is going to be this. Okay, so now I'm going to increase the temperature from 100 to where I want to end, which is 120. Okay, so again, when the graph is angling up, I'm going to do Q SMET. So we want to heat the steam to 120 degrees Celsius. Now this, again, kind of going back to look at how big that number was. This is why it burned. I mean, if you were to put your hand in boiling water, that would be painful. But in steam, it would be even worse. So I'm going to do Q SMET. Okay, so again, I'm going to use the specific heat that was given to me. The mass is 36 grams. And the change in temperature, we're going from 100 to 120, so it's 20 degrees Celsius. that again is going to be joules. So it's 14,333 joules. Okay, so now I'm going to go back and I'm just going to add all these numbers up. So I'm going to add up the 1973, the 12,040, the 1562, the 81,200, and the 1433. Remember, when we add, we base it off the fewest decimal places. So what I get here, my final answer is 111,708 joules. Okay, and it would be really good before class tomorrow to try number 4. In the textbook, I'm sorry, number 4 in the quiz. That would be a good one to look at. So, and definitely that's the kind of thing. Part of that, or that a problem like that, could be on the test that you guys have coming. Okay, and then I think that is probably a good place for me to go ahead and stop. We're going to finish we'll finish chapter 10 on Thursday. We may even get into we're going to skip chapter 11, maybe get into chapter 12. And like I said, depending, and we'll know if you watch this on Wednesday, if we're remote or what the deal is. But mid to the end of next week, we're going to have our next test. So, okay, guys, I will talk to you tomorrow.